So here what we're going to do is we're going to take a brief look at different errors that are possible when we're creating a primary standard solution and their effect on the concentration of the solution. Okay, so here the first example that we have is if our substance is impure. If when we're trying to dissolve a primary standard in a volumetric flask into a solution, if that primary standard is in fact impure and hence not actually a primary standard. So if the substance we're dissolving is impure, then what we have is we have to look to figure out the error, to figure out the result of this, the consequence of this mistake. Okay, we've got to look at the two equations that we use when we're figuring out the concentration. So one is we calculate the mole using N equals the number of mole equals the mass over the molar mass, and the second one is we use concentration equals mole over volume. Okay, now if the substance is impure, as I used as a brief example in the previous video on primary standard solutions. Okay, for example, if the substance is sodium carbonate, okay, then basically what we have is if the substance is impure, say we weigh 10 grams of this substance, okay, then we put 10 grams in here, okay, we put 10 grams into the equation here, we work out the number of mole, and from there we work out the concentration, okay. Now if this substance is impure, and so we've weighed 10 grams, however we actually only have 9 grams of this, okay, so we've weighed 10 grams here, or should I say, we've put in 10 grams here, okay, but we actually only have 9 grams because there's another whole gram of impurities in here. So if we actually only have 9 grams, then the actual mole, okay. Now keep in mind that when we're looking at errors, we're basically comparing the actual concentration to the calculated concentration. Okay, so here we've used 10 grams in calculations, however we should have used 9 grams. Okay, so that means the actual mole is going to be less than the calculated mole. Okay, why is that? Because here, this is the calculated mole. We've used 10 grams, which was a mistake. Okay, but here, in reality, we should have used 9 grams, which is less than 10. And because we're looking at the denominator, we've got 9, which is less than 10. And so the actual mole is going to be less than the calculated mole, for which we used 10 grams. Okay, so that's the first key point to look for. Okay, the actual mole is less than the calculated mole. Okay, now as a result, if we say the actual mole is less than the calculated mole, then we look at its effect on this equation. So if the actual mole is less than the calculated mole, then that means that the actual concentration is also going to be less than the calculated concentration. Okay, so what we're doing is we're going through step by step and seeing the result of our errors at each point in the calculation. So the actual concentration is going to be less than the calculated concentration. Okay, because of these impurities, okay, we've actually got 9 grams, we thought we had 10 grams, okay, and as a result, you can almost logically skip this process and think, oh, we thought we had 10 grams in the solution, we only had 9, okay, and therefore the concentration is actually lower than what we calculated, okay, which is what we've got. Yeah, so that's the actual concentration is less than the calculated concentration due to this error. Okay, now another possibility is that if we've underfilled the flask. So here I've shown, although we're supposed to fill a volumetric flask such that the bottom of the meniscus is on the line, here the top of the meniscus is touching the line. Okay, so that means we've underfilled the flask. Now, this one's quite simple. We don't even need to think about this equation, we just think about this equation. Okay, so if we have the concentration equals mole divided by volume, okay, now the volume here is less than it should be. So we've used, say it's a 250 ml flask. Okay, we've used 250 milliliters in our calculations because we think there's 250 milliliters of solution. However, in reality, we've underfilled it, so we actually have less than 250 milliliters. Okay. Now, if we've used 250 milliliters in our calculation, but we should have used less than 250, then that means our actual concentration is going to be larger than our calculated concentration, okay? So if we decrease V, okay, which we should if we fix the error, then that means our concentration will go up because V is on the denominator, okay? So in reality, our volume should be lower, which means our concentration should be higher. It means our actual concentration is higher than the calculated concentration, okay? So the actual concentration is greater than the calculated concentration. Okay. The volume that we used 250 milliliters. We should have used less than that. The actual volume is less than 250 milliliters, and therefore the actual concentration is greater than 250 milliliters. Is greater than what we originally worked out. Okay, so the actual concentration is greater than the calculated concentration. And these are two examples of how we can work through a process and figure out how the error will affect our calculations.